So let's start with the parser. The role of the parser is to receive SQL queries and convert them to a parse tree. After parsing, pre-processing and converting the parse tree to initial logical query plan also usually happens within the parser. As I mentioned before, these building blocks are representative and not exactly the same in all database management systems. For example, you can find Oracle's query processing diagram in the link below. Parse tree is a tree with nodes that are either atoms or syntactic categories. Atoms are the leaf nodes. They do not have children. They are lexical elements. For example, keywords such as select or where, name of relations, name of relation attributes, constants, or parentheses and operators. Syntactic categories are names for categories of query subparts, like a query, a condition, or attribute. They are to show that they can be substituted by an element of that category. We should define the rules to parse our query to those elements. The syntactic category query define queries of SQL. Let's, as an example, define for it one rule that defines the select from where syntax. In this representation, we read the : equal sign as can be expressed as. Query syntactic category can be expressed as select list, from list, where condition. Note that this is a simplified syntax, which does not include distinct, group by, order by, or other possible queries. But we start our discussion with this simple example. So, we define the rules for select list, from list, condition, attributes, relation, pattern, and so on. For example, a select list is either a single attribute or an attribute, a comma, and any list of one or more attributes. For example, in a SQL query, select name from students, cell list is name. From list can be any comma-separated list of relations. Condition represents SQL conditions that can be, for example, in a where clause. Attribute is representative of any string of characters that identify an attribute of current database schema. Relation can be replaced by any string of characters that makes sense as a relation in the current schema. A syntactic category pattern can be replaced by any quoted string that is a legal SQL string pattern, like 19%. We will see a full example shortly. Example parsing rules for select list could be select list can be expressed as attribute, comma, and the select list, or select list can also be expressed as attribute. From list can be expressed as a relation, comma, and a from list, or from list can be expressed as a relation. Note that the repeated syntactic category on the right side of the expression is used for deriving the repeated elements of the same syntactic category through recursive application. Similarly, a condition can be expressed as condition and condition. This is when your condition uses logical AND. A condition can also be expressed as attribute in open parentheses, query, and close parentheses, which is the case for using subqueries in where clause. A condition can also be expressed as attribute equals attribute, or expressed as attribute like pattern. And don't worry, we will see shortly a complete example. Here comes the exciting part. How do we use these rules? Let's see an example using a movies database. Assume the schema of a relation named stars in defined as movie title, movie year, and a star name, which is designed to show which celebrity stars in which movie. And a schema of relation movie star, defined as name, address, gender, and birth date, which is to store the celebrity information. We have written 2 queries to find the titles of movies that have at least one star born in 1960. The first query, A, selects the name of movie stars that are born in 1960 using pattern in the birth date attribute in movie star relation, uses that in a subquery, and finds the movie titles with those stars in the outer query from the stars in relation. The second query uses in the from list the relations stars in and movie star and selects movie titles where star name is equal to name and the birth date attribute from the movie star relation matches the pattern including 1960. These 2 queries are trying to return the same tuples, but with different queries. Query A results in the parse tree A, and query B results in the parse tree B. If we name the root level level 0, which is the syntactic category query, in both parse trees, the first level is the query expression we defined in slide 5. Then, the application of each of the expressions to the syntactic categories of select list, from list, and condition in the next level has resulted the trees as we see. Check these trees, and for each of the syntactic categories, try to tell which rule of the list we reviewed is applied. I will give you 2 examples. Select list in the query A uses the rule select list is expressed as attribute. And then the attribute is substituted in the following level with movie title, which is the name of the used attribute. Second, the condition in the query A uses condition expressed as attribute, like pattern. And the pattern and the attribute are substituted in the next level. Can you find the rest? After we have the parsed query, we perform preprocessing. Preprocessor has a few functions. One of them is checking the relations to find out if they exist or if they are actual relations or views. If they are views, which is basically a query on a table, the view is replaced by its generated query. Another function of preprocessor is checking and resolving attribute uses. It would check for attributes in select and where clauses, locates them in the relations, checks if there is no ambiguity, and ensures the correct usage. Another function of preprocessor is checking types. All attributes must be of a type appropriate to their use. For example, the types of attributes being compared should be of appropriate comparable types. In short, performing semantic checking, including checking relation uses, attribute uses, and checking types is the responsibility of the preprocessor.